Hello again. Now we are moving to the south of Spain to introduce you to Pedro Pardal. He has software engineer and technical coach from Malaga. He has worked as a developer and tech lead for nearly 10 years in multiple companies across Europe. That's a lot, Pedro. And now he's helping individuals and teams to become better at delivering high quality software by helping them to apply extreme programming practices and software craftsmanship values. Pedro, it's your time to rock.
Okay, so thank you, Carmen, and thanks to all the organization of the event for preparing everything on this short period of time. I've been following mostly all the talks today, and they are awesome. You've made a great job, and thanks everyone who's watching. So let's move on to the talk. This talk is called ALT and ENTER driven development. So the idea of ALT and ENTER driven development came almost as a joke when pairing with Michael Cheese. As Carmen said, I do technical coaching to developers and teams to help them become better at producing high quality code. And one of the things I do is I encourage them a lot to use the IDE more efficiently, right? So, for example, with my current team, we use Visual Studio with ReSharper, and when we're writing code, I always say to them, like, put the mouse here, press Alt-Enter, and then the IDE suggests what action to take, and it writes the code for you, like creating a method or a new field or something. And one day, a colleague told me that was like Alt-Enter driven development, no? That the code writes itself, and the developers are going to become useless, and and yeah. Fortunately, no, it's not the case. The IDEs don't write all the code by themselves yet. We have to tell them what to write, but not necessarily character by character. That's the point. So, and it's not only Alt-Enter, but I've seen many other bad habits while coaching others. And we will talk about some of them in this talk. So, in a broader context, I would define Alt and ENTER driven development as coding taking the most advantage of IDE features in order to, first of all, maximize productivity, and second, reduce risk of introducing bugs. So, as I said, this is not only just pressing Alt-Enter, but all the other features that modern IDEs include, like code snippets and automated refactorings, hotkeys, and most important, all the good habits that we have to adopt as developers to take advantage of all these features. So in this talk, we will be doing some live coding to show in action some of these habits, and we will go through some tips that will help you raise your productivity when coding. So first thing I want to show you is how to think that I call programming backwards. Okay, I think it's the most important habit we need to adopt for using this way of programming, and it's this very simple idea. So instead of when we're started writing code, instead of thinking about everything that our program should do and start writing from top to bottom, like we usually do, we first declare the variables, then we write the logic, then we do the return statement, and so on. So instead of doing that, what we're going to do is to code from bottom to top. To imagine we're writing a function. So we start with the return statement, and as if the rest of the code was already written, and we press Alt-Enter to the parts that are missing, so the IDE writes it for us. For example, new variables or functions and so on. This is going to be very natural for TDD practitioners since they already write the code in this way. But for all of you that don't necessarily write TDD, it has a very big advantage, which is that you write only the code you need, since every variable you created and every method you created was created because you actually needed it. So I'm going to show you with a live coding how this works. Let me go to the IDE. So we will do a small exercise called the bank kata. It's a small exercise where we have to implement a new class, bank account class, and the functionality to get the balance and deposit and withdraw some money. So we'll be using TDD for that and showing how to do these things. So let's start with creating a bank account shoot class or test for the bank account. And let's start by creating a test. You see, I'm using a code snippet for the test to stay more productive. You see, if I press Alt+Enter in the app test annotation, the IDE suggests me to import, so I don't have to write the import. And let's name this test. For example, a bank account should have an initial balance of 0, right? So applying the technique of programming backwards, what we should have to do, we should start with the last line of the method, which in the normal case would be a return statement. But since we're in a test, the last line would be an assert statement, right? So we write the assert. Assert equals, for example, that 0 is equal to account get balance. As you see, there are many things that are not there, so the compiler is complaining. But we just have to move onto them and press Alt+Enter, and then it suggests what kind to write. For example, if I press Alt+Enter on top of assert equals, I can add the import statement. And for the account variable, it will suggest me to declare the account. It suggests a weird type, but we can just write the right type that we want, which would be bank account. So now the next thing read is the bank account itself. So I can still press Alt+Enter to create a class and put it on the production code package. Okay. Then the next red thing would be this account, since it's not declared. So that we can, instead of writing the initialization, we could just press Alt+Enter, and the IDE suggests us to write the code. Same thing. Allow me for a second to split the screen vertically, so we have the test code and the production code side by side. Okay. So the next thing that is read is the get balance method, since it doesn't exist. So we just Alt+Enter, and there we have it. So we can run the test now, and should be red since we have an exception here. It should fail because of the exception. Okay, there we have it. So now for implementing it, as you can see, if we remove the implementation by default, the compiler is complaining here. So because the method wants to return an integer, but it's not returning anything. So you can see there, missing return statement. So we can also fix that with Alt+Enter. It suggests us either to make the get balance return void, which we don't want, or to add a return statement, which is what we want. So we add it, return 0, and that's exactly what we want. So we can run the test again. And there we have it. See, so basically we wrote all the tests without actually writing anything. We just wrote the part of the test, but the production code was completely generated. So that's the main idea. Okay. Allow me to go back to the presentation again, since I closed it by accident. Okay, so we are here again. So the next thing that I want to show you is how to take advantage of the IDE refactorings, which is a really powerful feature besides Alt+Enter, and which combined with Alt+Enter, it makes you really, really productive. So for this, I want to show you another small exercise, which is called the trip service kata. Basically, it's a small exercise aimed to improve working legacy code. There is a class trip service and a method that returns a list of trips given a user. This method have a particular thing that depends has some hardwired dependencies, like this user session. So we cannot test it. So the goal of this exercise is to take away this user session get instance, to inject it to the class, so that we can inject a mock instead of the real implementation, so that we can implement the test. Okay, but with the restriction that we only want to use IDE refactorings because we want to make sure that we don't break the legacy code and that we stay productive once we do it. So let's go to it. So the first step, we were going to be covering this branch of the code, this else, which basically throws an exception if the logged user that you see here is null, and this logged user comes from the user session. Okay. So first thing we will do is to create a test. We can easily create with ALT+ENTER, not save to the class, no, just create a test. So let's create a test class and allow me to split vertically again. So we have the test code side by side. Okay, perfect. So let's start writing a test. In this case, the test should be that the trip service should fail if user is not logged in. And we import everything with ALT+ENTER, of course. So applying, again, the backwards programming technique. We start with the assert, which in this case is to verify the exception. And with JUnit, we do this in the annotation method. So we expect that user not logged in exception will be found. The next step is to actually call the service. So we would write trip service. And in order to not write anymore, we just declare it as a trip service. And then here we can autocomplete all the stuff. We call the getTrip by user and we pass some user. We don't care which user is it. So we create it with ALT+ENTER. And again, we initialize all the stuff again with ALT+ENTER, 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 ALT+ENTER. Right? So then we have a compiler error here, which we can also fix with ALT+ENTER. It's basically saying that this method throws an exception and suggests to add this exception to the test method signature. Okay, I like it. And we would have a test. So let's run it and see what happens. Okay, it fails because there's a collaborator call exception, basically because we're calling this method, this getLoggedUse method, which we're not supposed to be calling because this is a unit test. So now we are in the point where we want to extract this dependency. So we would think normally how to extract the dependency. We will think that we will need some field to hold the dependency. We will need a constructor that receives one parameter, which is of type user session. This constructor would have to assign the field. Then here we will need to use the field. And then here in the test code, we will need to inject some mock code. That would be if we would write the code by hand, but we will want to use automated refactorings to make it faster and to make it safer. So when applying automated refactorings like this, the same principle of backwards programming applies. So we will try to do the same step, but in the opposite order. So we would start for trying to extract this from this method. We can, for example, apply the extract variable refactor here to extract this as a variable, and then this variable we can convert it to a field, which is what we wanted before. We can tell IntelliJ that initializes this in the constructor, so it generates the constructor and the field for us, and this is much closer to what we need. And then here, the only missing step is that this should not be initialized in the constructor, but it should be initialized outside and injected in the constructor. So we can apply introduce parameter here, and this does exactly this, what we want. So you see that now it turned it into parameter, and then the original value was put here in the test code. So we have already our dependency extracted. And then here in the test code, we can just extract this as a variable, and then here replace this instantiation of the real user session class for example, for a mock using Mockito. I can keep a mock user.logged-in exception, that class, and then we are injecting them up already. Oh no, this is user session, not the exception. So now we can run the test again, and it should be green. Perfect. So we have done all this refactoring only using automated steps using the IDE. So this is much safer and much faster than doing it by hand. Okay. So next I want to show you some productivity tips on top of these two good habits, but they're also very related to this. First one is, of course, to use automated refactoring as much as possible. So force yourself to change the code using only automated refactorings, or only whenever you can. But always that you are changing code, consider how that can be done in an automated way. Yeah. Basically, because it's, as we said, more efficient and safer. It's more efficient because you don't have to write the code. The IDE already knows how to write it and knows what parts need to be changed. And it's safer because if you do it by hand, you can introduce mistakes, but the IDE isn't that likely to produce mistakes. So it's been coded for that. So probably it's more safe. So the next tip is lend your toolkit. So for example, I've used IntelliJ in the live coding, but if you use another language, I use Java, but if you use another language or another IDE, investigate about the possibilities of the IDE, because most modern IDEs out there today have similar features. For example, Eclipse or Xcode or Visual Studio with ReSharper, whatever, all of them have similar features. And so dedicate some time to investigate about the possibilities. And this is a thing that takes me naturally to the next tip, which is practice a lot with code katas. Dedicate some time aside for deliberate practice. Basically, you don't want to be doing all this research while at work, maybe, but you want to do it like I don't know, maybe dedicate 1 hour per week to become better. There are things like this. It's not that much, and if you dedicate just that, you're gonna be better than most of the people out there, probably. But very important when you do katas is that what we seek when we're doing katas is not to solve them, but to practice the habits and give us some time to internalize them by repetition. So if you solve the kata just in any way, it doesn't count. You have to solve them by applying all these habits and so on. Very important. So next, next tip would be to use the code snippets for all the boilerplate code that we write over and over again, especially if you're writing code in languages that are very verbose, like Java or C# or something. They tend to be very verbose at times, like, for example, creating a test suite or looping over a collection or writing a test case or writing a log line or something. It's things that we write all over and over again. So if you have a code snippet that you can write one single word and then unroll all the stuff, it would be much faster. And for example, one of the snippets that I like a lot is if you're doing TDD, is to configure the default body of a function as to throw an exception, because this way the code will break when running the test, and you will remember exactly where you need to go to make the test pass. So you don't have to remember, where do I have to look to fix this test? Okay, you have the exception, you have a trace, you just follow it. It's like having some breadcrumbs. So next tip, it's to get used to navigation shortcuts. It's very fast. This is especially useful when reading code or changing legacy code, which, by the way, there are things that we probably dedicate even more time than to just writing greenfield code. And it would be nice to internalize some of these things, like go back and forth in the code, navigate inside a code file, how to go to a line, collapse and expand code blocks, move code away, navigate to different files, and remove or duplicate code, stuff like this. You wanna internalize that and internalize the shortcuts needed to do that. More things. Get used to use the keyboard instead of the mouse. Basically, there's a lot of things you can do with the mouse. Almost everything instead of but writing the code. But most of them are done faster with a keyboard if you get used to it. So I'm talking about things like opening the refactoring menu, finding a file, navigating to another file, all that stuff that I mentioned before. You can do this with a keyboard more efficiently. So and it's also very, very efficient, not having to switch your hand between your mouse and your keyboard. It gives you a lot of agility. And it seems like it's a micro optimization, but at the end of the day, if you adapt all the times you do this, it's a lot of time. So force yourself again with katas to learn the hotkeys and avoid using contextual menus. And use it only when you're learning something new and you still don't know the hotkey. And use them just for the next time you do this, remember the hotkey so you can use it. So next tip is to try to use always the same keyboard configuration. Ideally, everybody says that English is the most optimal layout for developers, since the semicolon and the bracket and these keys that we usually use, they are more accessible. I agree. I think that's the case. But the important thing here is that pick the one that you feel most comfortable with and stick to that one. Don't change it. Don't let the case happen when you don't know where the semicolon key is because the keyboard layout changed. You're gonna lose a lot of time for that. If you use many computers, for example, try to use the same configuration in all of them. The IDEs will allow to export configuration between computers, and you can even put a configuration in version control. For example, if you want to spawn a new machine, or you buy a new laptop and you wanna recover your settings, you can have them under version control and restore them very fast. And finally, last but not least, invest in proper setup, especially a keyboard. I think that's the most important tool for us developers. And I've seen a lot of people, for example, that have a keyboard in bad shape and they press the key several times and no character appears, and they introduce typos and they lose a lot of time using this. And these things should ideally not happen. It's just a matter of investing in a little bit in some quality equipment, a quality keyboard, and compared with the boost of productivity you get, it's really easy and really cheap to solve. Also, if you're using different equipment at home and in the office, for example, you have a desktop and a laptop, you have both. You're gonna have to consider this, especially true, for example, if you use different types of keyboards, like you have a Mac and you have a Windows, that they have different key layout. I struggle a lot with that because the control and command keys are in different position. Also, the MacBook Pro has the FN function in the place where there is control. It's a nightmare. So also true if for example you have keyboards with different type of keys, a membrane keyboard or mechanical keyboard of the same MacBook Pro, which has a most horrible keyboard in the world, but it's okay. So I would recommend in this case that if you're in this case, that you get a wireless keyboard and you take it everywhere. So that you don't have to change from one keyboard to another, and you don't have to adapt to multiple keyboards, and you're productive everywhere from minute zero. Personally, I recommend a mechanical keyboard, especially, for example, I have a gaming keyboard which have really good feeling and quality and very slow response time, and that's also very good for us developers. we want the same from a keyboard than gamers. Yeah, and that's it. That were all the tips I have to share. I hope you found something useful in this talk. And if there were some of these tips you didn't know, I'm really glad you learned something new today. And that's it. Thank you very much for your attention, and enjoy the rest of the conference.
Okay, Pedro, so we have a couple of questions. Yeah, we have some time. The first one, have you tried using other languages like Kotlin with the same techniques?
Yeah, Kotlin, I usually code in Kotlin, in Java, and in C#. So these techniques apply to the three of them, at least. For other languages, for example, especially the dynamic languages like JavaScript or PHP, for example, I'm not sure that the IDEs have all these refactoring features already in good shape, and that they work properly, since most of them rely on type inference and that type of stuff. But it's worth trying to find it out. I mean the technique of backwards programming, for sure, it applies to every language, and the refactoring, it's a matter of research.
Okay. Okay. Another one. Is there any way to find code SMET or something like that with your IDE?
Yeah, for sure. There are some plugins that alert you about code space. For example, there is SonarLint. I don't know if you've tried, but basically, if you have used SonarQube, which is a tool for static code analysis, there are some IDEs that bring all this code analysis to the IDE, and some other plugins for other languages. That depends on the IDE you're using and the language you're using. Again, it's a matter of researching which is your particular case, but there are for sure some of them.
Well, thank you, Pedro, for your time. We have a couple of more questions. Maybe we will write down on YouTube channel to continue, or your Twitter also. For the viewers and even for you, Pedro, when we finish all the talks at 6 p.m., we will create a link for meeting everybody and do some networking. So feel free to join, and thank you again. See you later.
See you.
Bye.